I'm Ignacio Fuentes. I am a solutions architect for AWS, and I also happen to be local to the New Hampshire area. So I figured, hey, I like .NET. There's a .NET user group, and I'm sure they would they would be interested in learning more about how I can add GenAI functionality with AWS. At AWS, we have quite a few services and solutions that you can make use of to very easily in a familiar type of environment using tried and true SDKs that are following the best practices that you would see from a .NET library. So point being is you can very easily add GenAI functionality to your applications. So very quickly as introduction before we get really into the meat of things, obviously, and I'm sure that everybody here has heard that machine learning is growing, and we see it. Of course, we feel it when we go out on the street and we talk to anybody that is in tech, and we also see it in the business world. Right, we see increased spending of machine learning functionality. We see infusion of AI across all kinds of different areas of a given company. That can be, of course, in the IT space, in the tech space, the developers, they're adding AI stuff to their own environments. But even HR might be looking into some Gen AI functionality to add to their to their flows every day. And at the end of the day, it is, it does allow to create a different type of impact that maybe wasn't possible, we can even say 2 years ago. So all in all, artificial intelligence itself is, really any technique that can enable a computer to mimic human intelligence. So that's kind of a broad area. But then, a subset of that area can be machine learning. And we'll talk about, quite a few ways that you can add machine learning capabilities to your applications. Machine learning also has, very, very specific, types of approaches to consume it and to work on it. And that can be with an example of that is classification machine learning or predictive functionality machine learning. But then a subset of that as well is the Gen AI, which is what really is the new buzzword out there, and that is a subset at the end of the day as well. But the point now is not about classification. It is not about just simple predictions, but it is more of a broad a broad approach for producing things. In this case, it can be for new content or new ideas, and that's powered by foundation models. And we'll talk about that, in a little bit. But like I said, it is, Gen AI essentially is a type of AI to create new content and ideas. And you can think about it as conversational type of situations, but it also can be about like, hey, I need a new story. Can you create a new story for me? I need images. I need videos. I need music. So it is powered by machine learning, but it is just thanks to the power of foundational models, it really can serve all kinds of situations, and it's not specific to one thing. So, I think this graphic here illustrates the big difference. So a traditional machine learning model would be very specific for a task. They would be task specific, right? So one can be about text generation, and you use one model for that. You can have a model for summarization. You can have a model for information extraction. And do not get me wrong, those really, they still have an important role in an application. And in fact, they can, you can use a combination of a traditional machine learning model with a foundation model. But a foundation model is all about, an unknown use case. And the model basically is useful for all kinds of situations. So unlabeled data on the left, you don't need to really, do a specific type of training on that. You consume the foundation model, and that foundation model can be used for all of these tasks that I just mentioned: text generation, summarization, information extraction, etc. So that's the core difference that's that has unlocked so many different and new business use cases for applications thanks to foundation models, large language models as they're referred to as well, and just overall the space of Gen AI. So like I said, new experiences. It can be about creating new content, but it can also be about productivity. Think about the scenario of maybe you work at a contact center and you get a call from a customer, and you need to help this customer. It could be the case that you have an application powered by Gen AI that is listening through the conversation, and it's let's say querying past tickets that resemble the case that you're trying to tackle, and it can give you live suggestions on how to help the customer at that given moment. But it can also be about extracting insights and just overall, unlocking creativity with creating content. So we see it, we see it in many different areas, and we're happy to talk about any use case that you guys feel you want to explore with us. We're happy to have a conversation. But AWS, this is kind of what we're here to talk about. How does AWS help with adding Gen AI functionality to your applications? And we kind of see it essentially in three main areas, right? At the very bottom of this stack is the infrastructure layer. So think about your virtual machines, or your EC2 instances, and we have chips that are purpose built for these use cases. So if you really want to roll up your sleeves and start creating your own your own applications using machine learning, we have purpose built machines just for that. At the top of the stack, we also have applications that they themselves leverage large language models and foundation models, so that you don't really have to build the applications yourself. And here I am talking about Q. And Q, you can think about it as an umbrella of different products. So here we have listed Amazon Q Business, Amazon Q Developer, Amazon Q in QuickSight, and Amazon Q in Connect. Q, like I said, is it sits at the top of the stack, and the point being is it's about creating rich Gen AI driven experiences for different situations. For example, if we think about Amazon Q for Business, it is about let's say you have your own business and you have your own potentially critical or privileged data, and you want to create, let's say, a chat experience with that data, potentially, let's say, for an internal, an internal employee portal, right? And just like the example that I mentioned, so it will be able to answer questions that are specific to your business. It won't be just a foundation model that's only trained in world data, so it can answer who won the soccer World Cup in 1994. I mean that would be world data. It is trained. It is meant to be trained on your business data. So that's Amazon Q for Business. But also for, let's say, if we're thinking about the persona of a developer, an engineer, right? Q is there to help make that engineer more productive, and that can be in the form of code generation. So as they are literally writing code, Q can auto suggest, auto complete, basically create the code along them, so that at the end of the day, of course, the developer is more productive. And from there, there's all kinds of use cases. For example, Q in Connect, Connect being a contact center solution from AWS, and that's kind of the use case that I was mentioning before, with the person at the other end of the line receiving help. QuickSight being a business intelligence tool. So again, imagine talking to a chatbot and telling it, hey, give me a charge of our sales from the past 3 months. in Europe or something like that, right? So Q sits at the top of the stack, so that without really having to code, you can get Gen AI powered applications. But at the middle of the stack is where we see Amazon Bedrock, and you can think of you can think of Bedrock as yeah, I like to think it as in a way as an API gateway that allows you, it gives you the flexibility to choose, what foundation model you want to use. So you basically interact with Bedrock, and you say, hey Bedrock, I need to interact with the the Claude model, or hey Bedrock, I need to interact with the Amazon Titan foundation model. And that's the core of it. Of course, from there it's got support for retrieval augmented generation, and we'll talk about that in a bit. It's got support for helping you choose what's the best model that you should be using. It's got support for actually helping you build the applications via a feature called Bedrock Agents, and we can dive more deeply into that one if you like. But the point is that it is about understanding that the future is not just about one model and then you rely on that. It is about when you're writing an application, and in that application you want to add Gen AI functionality to it. You want to make sure that you're using the appropriate model. And when I say appropriate, I choose that word carefully, because it's not about choosing necessarily the most powerful model, because maybe you don't quite need it, right? Now, that's not to say that the most powerful model is not in Bedrock. It absolutely is. But the point is you can use, and you see the list here, you can use quite a broad set of models on your application, and Bedrock gives you that one central place where you just, with a couple of parameter changes, now you're interacting with a different model. And like I mentioned, quite a few options, and in particular, you probably want to take a look at the Claude family, Claude 3 family, that's also part of Bedrock. And this gives you an example of what I was referring to before, right? Claude 3 itself, comes in a few flavors. So you can use Opus, Sonnet, or Haiku. And depending of your needs and the cost expectations on your part of what you're trying to build, you might want to choose the fastest and the one that's got the lowest cost, which is Haiku, or you can use the most intelligent and the highest performant, which is Claude 3 Opus. And all of that comes with built into the Bedrock experience, so that you don't have to just choose one model and stick to it until the end of days. You have the flexibility of changing, tweaking a couple of things, and now you're interacting with another one. You don't have to download anything complex. You just basically, you're using, in this case, the .NET SDK. You change a couple of parameters, and now you're interacting with a completely different model. Like I mentioned, though, it's obviously the case that when you want to write an application, you're trying to enrich your application with Gen AI functionality, you probably want to cater it to your use case or your customers or your data. And that's, it's a common approach that is natural. And one can be with just the right prompt. So if you're sending a question to a chatbot, and then you provide enough context for the LLM to respond, that we would call, and it's a lot more complex than that, of course, but that's essentially the prompt engineering approach of interacting with the LLM. And the other one is the retrieval augmented generation that I mentioned before, and that is there's quite a few ways that you can do this. One is, of course, manually you create your own vector databases, and with an embeddings model, you basically store your data in a vector database. And I can give you an example of that. For example, here's one that I like. The words will be stored in the vector database, so that they have they're stored in a three-dimensional space. And think about it. If you have a dog and a cat, there are similar concepts. So in this 3D space, they would be stored in proximity, in relative proximity to each other, whereas the other things might be quite far. And this enables and this unlocks, functionality that would be very hard to do without it being in place. So, for example, let's say that you want to search, and we would call this semantic search, right? Let's say you want to search for you're looking for golf shoes, right? If you're implementing this with rudimentary, just keyword search, the result that you might get might not be useful whatsoever, because the word golf might be a hit, but then you might get back like a golf bag, right? And that's not really useful. So with semantic search and using the vector database, embedding approach that I mentioned before, that will get you much better results. So retrieval augmented generation, like I mentioned, it's a powerful, important tool to have at your disposal as you're writing your Gen AI applications. But I hope that you would be at ease to know that comes built in as a Bedrock feature, and we call that the knowledge bases for Amazon Bedrock. Essentially, it's a managed retrieval augmented generation functionality within Bedrock, so that you don't have to create your own vector database, and you don't have to think about how you store the data in vectors. As I mentioned before, it will be taken care of by Bedrock. Now, again, you absolutely, if you feel comfortable, we absolutely support you to create your own vector database and point Bedrock to it. That's absolutely supported. But we also wanted to add a kind of like an easy button for this. And you see these are the many different types of database engines that you could use for vector databases on AWS. I'll just mention that the most common that we see are OpenSearch and OpenSearch serverless on AWS. You can also use PostgreSQL with the pgvector plugin. So there's quite a few approaches. Now, at this point, you might be wondering, okay, what does this have to do with .NET? And the answer to that is that the AWS has quite a few SDKs for interacting with our many services that are relevant for machine learning and Gen AI. So I want to give you a few examples of that, just for illustrative purposes of how predictable the experience might be. So as a summary, when you use the SDK, it'll be basically in the same place. It'll be a NuGet package that you install onto your application. And they all have this very familiar API to them. They're cross-platform, so you can use them in .NET Core or Xamarin or a .NET MAUI application. And it basically gives you programmatic access to all of the functionality that's available as part of that AWS service, right? So you think about Bedrock, or you think about any of these services. None of them are specific to any programming language or framework. They just exist as an API, and then the SDKs interact with them basically as a wrapper around that API. So the pattern is as simple as you create a client, and the client will be, you see it here in yellow, basically as a placeholder for the name of the service that you'll be using, and then you call any of the methods that are available on that specific service that you want to interact with, and usually it's an async method, so you will be using async await. So again, as an example, let's say that you want to use Amazon Textract. Textract is one of our services, and it's not the central purpose of the session today. But let's say that you want to use Textract for extracting text or handwriting from a document. You can absolutely do that, and hopefully this text is visible enough. But as I mentioned, you create a client calling a new Amazon Textract client, and like I mentioned, that's just essentially a NuGet package that you install, and then with the parameters that are appropriate for the call that you want to make. In this case, is analyze document async with a simple request object. you'll get a response back. And this pattern is exactly the same for basically all of our services. We have an image and video analysis service called Amazon Recognition. Again, think about it for maybe for facial detection, or for getting an understanding of what is in an image, as what objects are in the image, or what maybe you need it for content moderation if there's anything inappropriate, all those kinds of things. And the API and the SDK is very predictable. You create a client, Amazon Recognition client, and then you invoke the method that you want to invoke, usually with an async moniker to it. So in this case, await recognition client detect labels async, and passing in your request, and then you get your response. And it's very well documented. But in my opinion, more importantly, it is very predictable and standard. The same thing will be with Amazon Translate. Self-explanatory what it does. It can help you translate, language from one language to text from one language to another. The same thing for if you need speech to text. That's for that we have Transcribe. And the same thing if you need, text to actual, voice to speech. There's a service that does that the exact same way. Comprehend. We don't really need to get to the details of all of these. Like I mentioned before, Q in particular is it's an umbrella for a few services. Q Developer is the one that will help you as a let's say a C# programmer. It can help you produce the code. It can generate the code for you. You can actually talk to it and say, hey, I need help with this piece of code. How would I create a function that takes this and returns this, and it should generate the code per that prompt. And it supports the the languages that you might expect, of course, C# and TypeScript and JavaScript if needed, but a lot more stuff, right? Like Python, PHP, Go, etc. And of course, one that's critical, as I was mentioning before, for writing a Gen AI application is Bedrock. And hopefully you'll be glad to hear that the experiences and the way to interact with it is exactly the same. You will create an Amazon Bedrock runtime client, you pass it a payload, and then you invoke the model that you want to invoke. In this case, for example, you'll see that we're using the Claude model defined in this string at the very top. In this case, Anthropic.Claude-v2. And in fact, we probably want to take a look at a demo of this. And right on time, Ty, do you want to show us a demo of how this works?
Sure. So, hi folks. My name is Ty Augustine. I'm an AWS specialist solutions architect. I specifically work on Microsoft workloads. Before coming to AWS, I was a .NET developer building line of business apps for 20 plus years. And just to double click on some of the things that Ignacio said about Amazon Q, we have something coming up in the near future that was announced at reInvent later last year, called Amazon Q Code for Refactoring. And, part of my job is to help customers migrate and modernize their data centers, thousands of applications over to AWS. And oftentimes customers want to know, how do I modernize my .NET framework workloads over to, say, .NET Core? And we have tools for that today, but, some of those tools, you still have to do a little bit of work yourself. The tool's going to only get you but so far. But with Amazon Q for refactoring, embedding generative AI into the tooling now, what we're looking at is the tool being able to iterate over your code. And every time it iterates over your code, it can make a unit test as it starts to migrate and port that code over to say, .NET Framework to .NET Core, which is really, really cool. And ultimately, what we're looking at is.
Are you sharing your screen or something?
No, not yet. Not yet.
Oh, okay. Okay.
Not yet.
Sorry.
Amazon Q is not Amazon Q for refactoring isn't something that it's going to be going into private preview later on this year. But I just wanted to bring that up. But so let me just share my screen. Okay, so what I've got here is a demo. Let me see if I can move this pin. Can I move this? I don't know how. We don't use Teams. We use Chime. Sorry. Okay, so this is a demo of all the different foundation models that Bedrock currently hosts. So we have AI 21 Labs. We have Amazon. We have Anthropic. We have Cohere, Meta. Stability AI, and each of these different models have they have streaming support. They can run sync or async, and they also have different modalities. They can support image or text. Even some of the embeddings that we have, like Amazon's multimodal embeddings, support text and image, which means that you can do vector searches against text, but also images, which is really, really cool. And I don't think any of the other models, embedding models, really do that today. But the issue that we have with all these different models is that these different models have different input and different input and output, have different requests and response payloads. And by that, I mean, let me just show you. So what I'm going to do is I'm going to go into my AWS console, and I'll show you what that means. So I'm logging into my console. I'm going to go into Bedrock, and I'll show you what I mean by that. So if we take a look at some of these base models, and we take a look at, say, Claude 3, and Ignacio showed you a Claude 2. So even from going from Claude 2 to Claude 3, there's a huge change. So the request for Claude 2 looks like this, but then the request for Claude 3 looks like this. It's completely different. And that goes from model to model, unfortunately. So and then the responses are also different. So for Amazon, it's expecting this input text, and then for stability diffusion or stable stability AI, it has something called a text prompts. So all these different models have different inputs and outputs, which as a developer can be very difficult. So if I even take a look at my code, and we take a look at, say, what Claude 3 looks like, this is the object that you have to pass really as the request body. And then for like Amazon Titan text, it looks like this. So again, as a developer, this can become very painful if you just want to try out different models. So as a developer, I'm still a developer. Although I do all these different things at work, being a developer is still one of my biggest passions, and I'm one of the core contributors for an open source project called LangChain for .NET. And so I'm not too sure if you're familiar with LangChain. LangChain is a very popular AI ML orchestrator in Python. The goal for the .NET project is to port that project over to .NET. And I've ported over pretty much all the I've ported over all the Bedrock models, SageMaker, OpenSearch, and knowledge base. So what does that look like? So rather than having a whole bunch of these different interfaces to deal with all these different models, LangChain provides you just one interface. So, in this particular case, I'm getting my model by a particular model ID, but then I have this one interface that can be used for OpenAI, for Ollama, for just about any other model, any model that's out there for Bedrock and all the different Bedrock models. You have this one interface that you have to deal with, and you can pass it whatever options that particular model needs. In this particular case, I just wanted to pass whether or not it's using streaming or not, and then if it's using streaming, then you can do this, or you can get the response and you can just print it out, which is really nice because it gives you this layer of abstraction on top of those input and output requests and responses, which is really, really nice. Okay, so but I just wanted to mention that. So let me just go back to this demo. Okay, so here are the different foundation models. We have we have a text playground here. All this code is published on a GitHub repo that we can publish. We have a chat here. We have an image playground. These are all things that I'm sure that you've seen before. But we also have this PDF playground. And what this PDF playground does is, in the background, what I've done is I've created, in my Amazon account, I've created an OpenSearch endpoint. And OpenSearch is a vector database. And I've created this OpenSearch database in Amazon. This is my index in OpenSearch is like the database name, and then I have my login credentials. And what I can do here is I can drag and drop a whole bunch of PDF files. These PDF files, what it'll do, it'll go through each of the pages of the PDF file, grab the text, convert the text into vector embeddings, store those vector embeddings into OpenSearch, and then I'm able to do a semantic search against it. And I can show you what some of that code looks like. So if we go to the PDF playground here, it's quite a bit of code. What I'm doing first is I'm creating my vector store, and this is all just using the native Bedrock SDK. I'm creating my vector store. I'm saving a location for my PDF documents. When I click on submit, I'm adding, for each of those PDF files, I'm adding the documents, and I'm adding those to the OpenSearch vector store. Then when somebody queries against it, I have a question that comes in. I convert that question into an embedding, and then I can do a similarity search against OpenSearch with the embedding that's being used as a question. And then I have a prompt. I can embed the context from all the similar documents that came back, and then I can embed this all into my prompt. And then I can go into my, given all this data, I can then query this against one of my LLMs, whichever LLM that may be. So there's quite a bit of code here. There's quite a bit of things that you have to do for, and this is pretty typical for every RAG implementation. This is the typical thing that you have to do. If you take a look at any particular RAG, and this is a simple version. There's other RAG implementations that do a lot more, but this is one of the most simple use cases. Amazon also has a service called Knowledge Base, and this also hangs off of the Amazon Bedrock umbrella. And with Knowledge Base, what I can do then is, and Knowledge Base is another RAG implementation, but with Knowledge Base, what I've done here is I've created an S3 bucket, and let me show you that. An S3 is one of Amazon's storage services. So in here, what I did is I created a bucket for my shareholder letters, and these are in here. What I've done is I've added a whole bunch of shareholder letters. These are public Amazon shareholder. Can everybody see my screen? Okay, is it too small? Okay. So I've added these shareholder letters, 2019 to 2022, and I've also added this metadata JSON file. Let me just show you what that looks like. So this metadata JSON file is basically describes, what company, and this could be anything that you want. This basically describes the company and the year. So I've done that for each of the PDF files, each of the shareholder letters that I've uploaded, and so I put these documents into a particular bucket. So then when I go back to my knowledge base, I create a knowledge base, and then in this knowledge base, I give my knowledge base a data source, and I can have one to many data sources. I think in this particular case, 5. So and then with this knowledge base, I'm kind of just pointing to my shareholder bucket, and I've also given it an embedding model that I want to use. And again, I have the choice of which particular embedding models, and that's the biggest power, I think, of Amazon Bedrock is, like Ignacio said, you have the freedom to do of choice. You don't necessarily have to use one model. One model doesn't necessarily fit all use cases. So so in this particular case, I chose the Amazon Titan embeddings model. So I've created my data source. I've given it an embeddings model, and then what I've done is I've selected one of a vector database. And again, there was choice of which vector database I can use. I could have used, PyCone. I could have used DynamoDB. I could have used PostgreSQL. But in this particular case, I'm using OpenSearch. So once I've done that, I'm then able to, and this is all done. This all happens behind the scenes, and once I've done that, I'm able to then query my model. So in this particular case, I'll say that I want to use Haiku, and in here, what I can do then is I can also add filters. Now, those filters, I showed you earlier that metadata. What I can do is I can use those filters to filter against that metadata. Like if I wanted to say what particular year or what company that I want to filter against. Here's my default prompt. But let's go ahead and ask a question. So here I've already done this. I've already synced up my data with my data source. So here, if I wanted to ask a question, like how many days have Amazon employees been asked to come back to office, I could run this, and you can see that it gives me a response. And it also, as part of the response, it also gives me these citations as to where it found these documents. So if I open up this particular citation, it tells me that it found it in this particular document. So this is all within. I'm doing this all within Amazon's Bedrock console. So I've also created a knowledge base here. And with the knowledge base, I'm going to do exactly the same thing. I have a drop down of the different knowledge bases that I have in my account. I'm going to select the shareholder letters. I'm going to do a hybrid search, which does a semantic and text search. And I'm going to ask the same question. it gives me back the same response. So what I want to do now is I want to just show you the code, the difference between the code of me manually creating this RAG application and then me using the Amazon Bedrock SDK to create the same thing. So this is pretty much the same thing, and here's all the code. Before I showed you all these different things with OpenSearch, and I had to move the data around. I had to create my OpenSearch. I had to do my embeddings. I had to create my embeddings. I had to do all these different things. Here, this is all the code. So here's my question. Here's the knowledge base ID that I want to query against. Here are my filters that if I wanted to add those same filters, and it gives me back the same response. So this is incredibly powerful because knowledge base does all the heavy lifting for you, which is really nice. Does anybody have any questions?
Yeah, very cool, Ty. I was wondering if there are some questions from the audience because that's a lot, but I'm sure that there might be some open questions. Go ahead, Uday.
Yeah, I have some questions. So you take a large PDF, right? So for example, you have a PDF 250 pages, right? When you putting into an embedding array, what is the size of the embeddings? How, I know you are not going to create a one embedding for 250 megabytes. You may have to slice it, right? Slice the document into multiple chunks, right? Yep. Can you explain me how you will handle the large PDF?
Yes. So
what is the embedding size when we use the Titan embedding?
Yes. So with the embeddings, what you would do is you would just pretty much chunk. You would just take pieces of the document and just make multiple API requests, and just push that and just push all those embeddings into your OpenSearch database.
Yeah. So okay.
So you wouldn't take the whole PDF all at one time. You would take it piece by piece and store each parts of those embeddings into the database.
Okay. Now, what is the Titan embedding size? I know the OpenAI, for example, gives the 1536, and then some of the Microsoft model, Vision model gives the 1040. What is the embedding size here on the Titan embedding?
Are you talking about the dimensions?
Yeah, the dimensions, yeah.
Yeah, the dimensions it's from model to model changes. Like if you on Titan embedding text, if you're doing Titan embedding text, it's 1536. If you're doing images, it's 1024.
Oh, okay. So that's the same thing as a Microsoft stack. Okay. But now when you have to store those embeddings into a index, do you create two separate index or same index since these embeddings are different size?
It's the same index. Well, if you're doing images and text, if you're doing a multimodal, because Amazon Titan also has a multimodal. With that one, you can do images and text. If you're doing just text, you can do it's 1536.
Okay, so I have another question. So if now say for example, you said okay, so I have a large PDF. You are not going to look at entire PDF. The dimension doesn't make sense, meaningless. So we slice into a multiple chunks. Now the dimension makes sense. Well, I'm looking for something, right? So I'm picking this as an example. I'm looking for washroom, for example, right? I know we set the max result to be 5, right? Now, when we slice the document, we have 3 documents that contains the washroom. But when we look for semantic search, maybe a bathroom or a toilet or a restroom, it is going to match it. But the one document contains 5 different chunks that's word repeated, but there is another 2 documents never been part of that 5 result. Is that the case? You see how this junking and retrieving the appropriate document works in this space? You know what my question is?
Yeah, I think I understand your question, and I don't know the answer to that.
Oh, okay. Okay. All right. Great.
Yeah, I don't know the answer to that.
Yeah. Keep going, please.
You mind if I ask a question?
No, feel free.
So, and mine is more, and I apologize, I don't know a lot here. It's more around a use case idea and understanding if Bedrock or these tools would be appropriate for it.
Sure.
I have a relatively simple online application, runs in the cloud. The application has a configuration stage to it, something that a lot of new users would do specifically as something as a proof of concept. I'm looking to try to see a way if I can get a Gen AI to help actually be an online consultant during the that POV or proof of concept. And as an addition to that, as the part of teaching it, is it possible to bring in transcribes of actual proof of concepts that would be the items that would be used to actually train the AI to know what to do? Is that reasonable or not? Is that something other people are doing?
I'm trying to better understand you mentioned transcribe. You're not talking about the AWS service to transcribe?
No, I'm talking about transcribes of like Zoom calls. So let's say a real live proof of concept with a customer where a human was walking them through all the steps of what to do in the configuration. Take that, basically the transcribe of that call, and have that be the input to help train the.
To me, I think that's the next version. That's going to be the next version of Teams, and it's going to have like some type of agent that kind of sits on the side, kind of listening to the conversation, and it's going to be able to give guidance to the speakers. I think, I absolutely, I think that's a fantastic use case. Okay,
not necessarily something there yet, though. Is that what you're saying?
I haven't quite seen it in out in the world, but I can see how that can become a very popular product. Yeah.
And then the other part of that, especially from the standpoint of the interaction I would want, would be one that would be voice driven. Is there also where you have the interaction where the AI can also help navigate the user through the actual tool that they're using? So instead of just saying you want to do this next or provide guidance, but also help control the navigation of their overall experience, like moving around from page to page inside of what they're doing?
Absolutely. Definitely. Yeah, in fact, as part of this demo, do I have maybe I have so many different versions of this particular application, but one of them here is a voice playground that's using an open source voice package that integrates with Bedrock. But absolutely, 100%.
All right, excellent. Thank you.
And to add to that, what you're describing, Michael, is a situation where you would use kind of multiple tools to build the one thing, right? So maybe a final one, or actually not the final one, but a component of that will be, let's say you interact via Bedrock with a model, but then the output that you get from there is something that you pass through a tool that maybe converts text to speech, right? So what you're describing seems absolutely plausible. It's just a combination of different tools that you will be using.
Okay.
Yeah, just to double click on that too. Like I recently saw a demo where someone used multiple LLMs and also SageMaker. So SageMaker is really incredibly powerful, and because SageMaker allows you to deploy other models that's outside of Bedrock. So you can go to something like, say, Hugging Face. Hugging Face is a repository that has all these different models. Amazon built a relationship with Hugging Face. If I remember, it was back in 2022, where you can deploy Hugging Face models directly into SageMaker, and then from SageMaker, something new that Amazon's just announced, or that's in preview, is you can then take some of those SageMaker models and host it in Bedrock, which is really, really cool. So to go back to my example, I saw an example where someone told Bedrock to create an image of ingredients, right? So it created this image of ingredients, and then it said, okay, look at this picture. Tell me what ingredients there are. So now another model is looking at the ingredients, because you have one model that creates the image, and then you have another model that's able to recognize what's inside this picture. And then it says, okay, based off of these ingredients, create me a recipe for this particular meal. So it was like, holy cow, wow.
Thank you.
Yeah, another thing that's really cool about these embeddings and with that I kind of alluded to earlier is that you can store images. Like one of the things that Ignacio was showing is you can not only just store text, but you can embed images. So and do semantic search against images. So what does that mean? So you can say you created, just going back to Ignacio's product catalog of golf shoes, right? So rather than it looking at the text of the golf shoes, it can say, okay, give me the golf shoes that have this particular color. And it knows what these colors, because it's doing the semantic search. It can do searches off of these images, which is incredibly powerful.
Very cool.
Hi, can I ask a question?
Yeah.
Go ahead, Vicky.
Yeah, so I'm curious, how is the document being parsed? Under the hood, is there another AWS service to parse the document?
Can you clarify what document you're referring to?
So, for example, the PDF rag playground.
Okay. Let's I'll show you. So if we go to the PDF rag playground.
And Vicky, you can see the screen, correct?
Yes.
Okay. All right. So if we go to the PDF rag playground, and let me just show you the demo of this, just so that you can put it, you understand what's happening. So let me just click on this. Here are my PDF files. I'm going to add these PDF files, and when I submit this, it's adding these documents. Now, what it's doing is it's going page by page. It's grabbing the text off of each of these pages, and then it's storing them into the vector database. So if we go back into the code to try to understand what that means, here is where I'm adding. So I have my list of PDF files, right? And for each one of my PDF files, I'm loading the documents. So I have all my documents here. And then in here, I'm going and this is what I'm doing. So I'm going through each of the documents, and I'm creating an embedding off of each of the pages in that document. I'm doing I'm doing this all as tasks, and then I'm converting all these into embeddings, and I'm adding the embeddings together, and then I have a record here, and then once I have all my embeddings, I'm just doing a bulk insert into the database, into my index. Does that answer your question?
Yeah. So for example, the PDF contains text, table, and charts. Will this reliably extract all those information, or it's only for text?
It's only for text.
But not tables and data in the tables.
It's extracting the text within the table. So anything that I could select on that PDF file.
Okay.
But
I think to add to her question, does it do the images in the PDF? So I know the table in the form of text will extract as a text extractor. Will that extract if there is an image that contains, something about your screenshot, what you saw there? Will it extract that as well?
It could, but in my particular example, I'm not doing that. To do that, I would have to use a multimodal embedder, and not only that, I would have to use a multimodal embedder, but then I would have to recognize those images within the PDF file, and then store those as well. So
what is that? Go ahead. Sorry. Go ahead.
No, I think I finished. I think I finished my thought. But you would have to be able to make sure that you're pulling, because the process that I have here, I have a custom process that's pulling out my text. But in your particular process and what you want to do, you want to be able to pull out the text and the image. But it's possible, absolutely.
Yeah, got it. Now, what is the assembly or open source or the techniques you use to extract the PDF?
Oh, I'm using a third part, an open search. I'm sorry, an open source library. Let me tell you what that is. It's ugly I think it's ugly PDF.
Oh, okay, got it.
Yeah, it's just a NuGet package.
Yeah, got it. Thank you.
Is it PDF Pig?
PDF Pig, yeah.
I have another question. How do you design the embeddings? Say, for example, I have thousands of documents, but these documents, all of them are pretty structured, meaning that one document contains different parts, and for other documents, they have exactly the same parts as well, like part 1, part 2, part 3. Are the embeddings going to capture those scope, or it's not the case? Like, no. I think it would be really nice that if the index can be built around these different parts, like say part 1, I want to create an index, and part 1 index has all the documents for part 1. So I can do a query against all the documents and filter by maybe some metadata around the year, around the company, etc., keywords.
Yeah, so that's where I think that metadata, in the case of the knowledge base, that's where you would need that metadata JSON file. But then you would need it for each of the different files that you have in your data store.
Each file in my data store.
Yeah, because your data store has structured and unstructured data, right? Is that what you're saying?
Yeah. I can have like PDF, or those PDF can be HTML. Then I can parse them into structured, more structured data. But I want to like reliably understand part 1 across all different documents, and do it like cost-effective way.
Yeah, one way might be to just convert the unstructured data into structured data.
Mm-hmm.
That might be one way, but I mean, you can certainly create embeddings against all of it, but it probably won't be it probably won't go into the embeddings as you like. But okay. but you can do that if you were to attach metadata files for each of the different files in there.
Okay. Thanks.
Yeah, yesterday I saw a customer have a really cool use case where they created an Outlook plugin that would look at the person's email, do some inference based off of their business. And when they clicked on this button, it did some inference. It went to Bedrock. It did some inference off of the email, and then it was able to craft a response email back out to the customer, which was really, really nice.
Yeah, I also like some of the use cases where you give the LLM as part of the context, for example, the schema of a database that you want to interact with, and then ask your prompt will be to give me a query to get this data that I'm looking for, and then that query gets executed, and then you send it back to the LLM so that it can give you the natural language response. So those, I've seen some really amazing use cases.
I have a very silly question. It is really a silly question, I guess. In your presentation, both of you used more often the foundation model, whereas you talk outside, most people will use LLM or SLM, like large language or small language model. What is the difference between foundation model and LLM or SLM? I know in your diagram, you listed everything as a foundation model. You never use the word LLMs. Here is the LLMs comes under Amazon's umbrella, but you said here's the foundation model come under the umbrella.
To me, I kind of use it synonymously.
It's interchangeable. Yeah, I think it's just interchangeable.
Oh, okay. Yeah.
But I think that's a good question.
Yeah.
Any other question? Do you have anything more to show or?
No.
No, that's yeah. That was.
You said you have a GitHub where we can download the samples. Would you mind chatting that URL?
Oh yeah. It's in my personal GitHub, but we do tomorrow. We're also pushing a lot of artifacts to the AWS samples, but yeah, I can certainly give you my personal GitHub.
Yeah, just give us where we can download the samples, so we'll publish it part of the video. So people wanted to download, play with the sample, they can do that.
Sure.
I just make sure there's no API keys or anything in there, right?
No.
So I have a question. Do you have any plan to source some samples that how you can integrate this with the semantic kernel? I know you focused more on the long chain, but I was just curious. Do you guys have any plan to show this part of the semantic kernel?
Yeah, so I built connectors, AWS connectors for semantic kernel, but I haven't published them yet.